Hello everyone. So today I'm gonna talk to you guys about VLC and video and Xamarin, of course. Okay, so let's get started. I'm gonna just tell you a little bit about myself because I don't really know anyone here. So I'm French. I'm 26. I live in Asia, and I work remotely for a French company, which have about 20 people. And I'm also part of VideoLAN. So I'm gonna mostly tell you about VideoLAN today. VideoLAN is a non-profit and VideoLabs is a company. So there are quite a few differences between that. But most of the people in VideoLabs are also in VideoLAN. You can find me on Twitter and GitHub, of course. So about VideoLabs. We are the official maintainers for the official VLC apps. I think most of you know about the VLC apps, I guess. We do a lot of custom multimedia solutions with telecoms, IP, camera, manufacturers, all kind of stuff. LibVLC, which I'm going to tell you about later, FFmpeg, various codecs, David, Ravi, which are new decoders and encoders for a new format, AV1. And lately we had a project with Mozilla where we added UWP support to their Rust compiler because Mozilla is starting to do virtual reality and they wanted to be able to write Rust applications for the HoloLens headset. So that's about VideoLabs. So I'm gonna first tell you about VideoLAN, VLC, the project, how it got started. Then I'm gonna go more into detail about how it works technically. And then, of course, I'm gonna tell you about how you can use it from .NET and Xamarin. So, a bit of context. So this is 1993, and some French students want to play video games, right? And they want to play Doom. And Doom, you can play multiplayer, like in a LAN. And at the time, they had token rings networks. Does anyone know what token rings network is? Okay. So basically, it's a network in a ring shape, and every time someone connects to it, the ring gets bigger, and every message has to go all around the ring. So the more people are connected, the higher your latency, which is not good when you want to win at Doom. So the students, they went to see the school, the university administration, and they said, we need a better network to work. But the school was not naive, and they knew that they just wanted to play video games. So they said, we cannot help you. If you want a better network, you just have to find it yourself. So those students really wanted to play Doom. So they went to see Bouygues. So Bouygues is a huge company in France. They do all kind of stuff, construction, telecoms, really a lot of stuff. And they came to them and they said, the students, can you give us a new network hardware? And Bouygues said, at the time, it was like 1993, Bouygues thought that satellite TV was going to be the future. So they said to the students, if you can manage to make satellite TV work on a commodity computer and decode a stream, then we will pay for your equipment. So for a couple of years, students at the school worked on that, and they managed to get it working, and we paid for a new network equipment. that's how VLC was born, basically, as a student project. And the reason I'm telling you this is also because from the start, it was network focused, as in it was not only being able to play local files, but from the start, it could play remote files, streams. And this is really important. So in 1998, new students came and new students started to work on it. And they decided to reboot the project and make it open source with a GPL license. But later on, LibVLC, which people can use in their apps, was relicensed to LGPL, which is not really common in the .NET community as a license, but I will tell you more about it later. It was cross-platform from the start, which at this time meant mostly Linux and BOS. Network-oriented. So like I said, VLC was actually a bunch of projects at the beginning, and there was a client and a server, hence the name VideoLAN client, VideoLAN server. But after the years, the functionality from the server component got integrated to the client component, and just VLC remained. So when you use libVLC, you can actually stream to other computers. That's part of the library. One of the other projects was X264, which is the leading encoder for H264 format. So, does anyone know the answer to that question? No? So, the code. It's actually a pretty ridiculous story. Sorry about that. So students game, but students also do stupid stuff when they drink, So one night they were out and they were just starting, the project was like 1995 or something, so quite a while ago. They just started the project and they had a name, but they needed a logo and they didn't have a logo. So they went out drinking a Saturday night and one of them came back with a construction code that he borrowed during the evening. And he just kept it, and it just became kind of a internal joke, inside joke, and they borrowed a few more. And when they were thinking, what kind of logo can we use, that just came. So it remained, and every once in a while we have someone coming on in the forums and they say, can you just change this stupid icon? It doesn't make any sense. And we don't. We're not gonna change it because it's fun and it doesn't make any sense, but at the same time it kind of does because it's always kind of a work in progress, always under construction. And there are a few Easter eggs, I think that's what you call them. Sometimes, like right few days before Christmas, your VLC icon on your desktop will change into this. So VideoLAN, in 2009, one of the lead developers created the non-profit organization VideoLAN, the same guy that created VideoLabs a few years later. So my boss, basically. So VideoLAN creates software, mostly VLC, X264, LibVLCSS, which is a DVD decryption library, LibLoe, LibDavid. One of the guy in the VideoLAN community maintains the Matroska format and the Matroska Foundation. So they do the MKV formats. So VLC does not have any tracking. So we don't really know for sure how many active users we have because VideoLAN is pretty, has a strong stance on ethical anything ethical, basically. So we don't collect any user data, we don't track anything, and we consider most analytics as user tracking. But our estimation is about 400 million active users, 3 billion downloads. This we can track without any issue. About 800 contributors total. So the core is pretty small in comparison. It's just C code, basically. Some assembly, some C++, but mostly C code. Plugins and contribs, then that adds up. I will show you more about this later. So, does anyone have any idea about this one? No? So we don't really make any money, but we also don't really spend any because we don't pay any developer. It's only volunteers. Some people have company on the side to be able to live, but VideoLAN doesn't really pay anyone to work. We do pay for like events, going to FOSDEM every year, or goodies, or stuff like that, but we don't really have full-time staff working on that. So about the money, it's just donations, basically. So I think that was in June last year. This is a tweet from the VideoLAN Twitter account. Right about when Microsoft bought GitHub. So VideoLAN does not really use GitHub. We are on GitHub, we have myROLs, so every time we push on our own Git, our GitHub myROLs get updated. But there is no, you cannot open an issue on our GitHub, it's locked. You can open a pull request, but on the actual VLC desktop apps, people will ask you to use the mailing list, which is pretty old school, and we are in the process of moving to GitLab. This is a bit different for the VLC ports, which is VLC for iOS, VLC for Android, and VLC for UWP. Those you can make a pull request, and some people do. So basically, we use GitLab mostly, GitHub for everything else besides the VLC desktop apps. Reason for that is because VideoLAN wants to be completely independent and in control of the whole toolchain. Code versioning and issues and all this stuff is very important when your whole business is doing software. So if you're doing that in someone else's garden and that person just makes choices that you don't really agree with, then that pretty much prevents you from doing your job. And you don't necessarily want this happening to you. That's why we pretty much use open source for everything, and all of our stuff is open source. You can see it at code.videolan.org. So 3.0, that was a release last year. Pretty big release. It had been a few years since we had a major release, synchronized on all platforms. So plays all formats. I have a paper here with a list of all the formats that we play, but I'm not gonna say it to you because there is quite a few. But you can have a look later if you want. Network browsing. If you have a file on SMB, your NAS in your home with your TV shows or whatever, SFTP, FTP, you can play it with VLC, torrents even. HDMI pass-through, Chromecast. I will also tell you a bit more about the Chromecast because there is some interesting stuff about it. But you can stream to Chromecast with your devices with VLC. 360 video and 3D audio playback. Ambisonics, 8 audio channels, subtitles, live modification. Hardware decoding. This is a big one. So for those who don't know, when you want to decode and display a video, you have basically two ways: using your CPU or using your GPU. Usually you want to be using your GPU because it's much more efficient to do it, and your battery is gonna be happy, and you can just use your CPU to do something else. So hardware decoding is, I think, really important. It also allows you to play really high definition videos, such as 4K or 8K, on really small but still powerful devices. Right. So every year, the VideoLAN organization goes to FOSDEM. Anyone know here what FOSDEM is? So FOSDEM is a big European open source conference. I think the mono people were there this year, but I wasn't. So we have a very skilled designer in the VideoLAN community, which has fun doing all this kind of goodies and displays. So I just wanted to share with you a few. This is useful. So, libVLC. So VLC is the app, but libVLC is in the same Git repo. So the distinction sometimes is hard. That's why I want to show you what is inside your hard drive when you install VLC. So right now, I don't know if you can see, but I'm in C program files VideoLAN, which is the installed directory, and I really need to zoom. I don't even see anything. View. No. Okay. Can you guys see? Okay. So you have a directory here called plugins, and we're back to small. Give me just 1 sec to see how I can zoom. So you have a bunch of directories here, plugins. (365 files, weight 123 megabytes. This is in your VLC installation library, installation directory, sorry. And when I was telling you about the numbers before, this is 12 million lines of code with all the dependencies. So that's a lot of code and a lot of DLLs, which you don't have to manage yourself, of course. So libVLC DLL is what you use from C#, and they handle the whole loading and unloading of all those DLLs. So how do we call C code from C#? You have two ways: C++ WinRT, which was called C++ CX a few years ago, which is how the VLC for UWP app works. It allows you to call C code from C++, but it only works on Windows 8 and plus, and that means if you want to use it on Xamarin, it's not possible. So what most people use for writing cross-platform bindings is platform invocation services, which is available everywhere. So that's what I chose when I started LibVLCSharp about 2 years ago. So LibVLCSharp works everywhere. Mono.NET and libVLC works. So we had a Tizen port for a few years ago, but didn't really work out. But you can still pretty much use it everywhere from shared code. So I'm gonna show you some code later, but I just wanted to show you, to tell you about the main objects. So libVLC, from which you can get a lot of information. It's the main object of the API. Media player, of course, with .NET events, playback, play, pause, stop, forward, all this stuff. A media, which is just an object which represents something you want to play, which could be a stream, which could be a local file, audio, video. Media discover, what you use for the NAS browsing and playback. Renderer discover, that's mostly the Chromecast, but we are also implementing AirPlay, and if I'm correct, there are some TVs, some connected TVs that use UPnP directly, so you will be also able to cast to it. And a video view. Yes, I wanted to show you a bit how our NuGet packages are organized. So it works, but it should. Or not. Yes. So, what do we have? We have two types of packages. Native code packages. So this is basically the C code, which I compiled for your platform, and I put it in a NuGet package. And the C# code, which calls on the C code, which are libVLCSharp dot something packages. So if you take the Windows one, for example, this is where you have your 350 DLLs. If you don't need those, all of them, you can remove them. If you know that your app will only play a specific kind of file, or you don't need a Chromecast or something, you can just remove them, or use MS-Build to just not copy the DLLs you don't need. So this way, 133 compressed, because there are 32 and 64 bits DLLs. This is what you use when you want Xamarin Forms support. So this is the .NET binding for Xamarin Forms. You have a .NET Standard 2.0 DLL, and Android, iOS, and the Mac build. The other ones are separate. You can use Xamarin Forms for WPF also. WinForms, GTK on Linux and Windows, and UWP, GTK. Okay. So that was a couple of weeks ago. We released that thanks to a lot of work from one of our contributors. So when you want to play a video, usually you use Google or Apple media players, and they provide you with something like that. So a view, but you also have controls. Before this, we just had a view. So Xamarin Forms view, or iOS, if you only use Xamarin iOS, or Xamarin Android view, and you just had the view. So people had to implement their own controls, the buffering, the SIGBAR, everything. So we thought that it would be nice to offer kind of a plug-and-play alternative, as in you can just use this and you don't have to re-implement everything. So, for example, with this button you can change the audio track. Some files, some streams have different audio tracks. This is for the subtitles. Elapsed and remaining time, aspect ratios, there is 6, that's already there. And you can just press it and automatically adapts to your screen. And this is a Chromecast button, which connects to your Chromecast or disconnects to your Chromecast. There are a few more things I'm planning to implement, but this is basically it for now, working on iOS and Android. Oh yeah, it's completely customizable and themable with Xamarin Form style. So if you want to hide something because your app only plays live streams which cannot be paused, you can just remove the play and pause button. If your app is always running in an environment where there is no Chromecast, you can just hide the Chromecast button, just remove it. If you want to change the icons, also possible. So about the Chromecast. Yeah, sure.
Xamarin Forms a sample. Where can we find it?
I can tell you that right now.
Is it on the same repository?
Yes. So in the LibVLCSharp repository, we have minimal samples, and I really insisted that we have as little code as possible. So you just have a video view that when you run it, you just have a video view which plays a video.
Yeah.
That's it. Because I really wanted people to see with minimal code and no trust and no bells and whistles. If you want to see more complex examples, there is a repository.
No, like that particular one.
The Chromecast one?
Yeah, the one that you were just showing me, the Chromecast.
Sure.
Okay.
So github.com/mfkl, which is my profile. Here you have LibVLCSharp samples.
Okay.
But yeah.
Okay. So just one of those.
Sure. I'm gonna walk you through a few of those of this repository during the presentation. And I think I lost my yes. Okay. Yes, Chromecast. So the Chromecast is a Google component, which is not open source, right? The VLC apps are GPL. When you use GPL code, it's really hard for you to use a library in your app that is not open source. When you use LibVLC or LibVLCSharp, you don't have this problem because LibVLCSharp and LibVLC are LGPL, lesser GPL, which means that you can use proprietary libraries and your app can be proprietary. You don't have to open source your app if you use LibVLC or LibVLCSharp. The only thing you have to do is if you have to modify LibVLC or LibVLCSharp for your own needs, you need to publish those changes, which I think is fair. But you don't need to publish your own code, and you can use any library, closed or open, that you want. This is the difference between GPL and LGPL. LGPL is pretty friendly with proprietary code. So back to it. The apps compared to the library, the apps are GPL, meaning that we wanted to add the Chromecast functionality to VLC for a while, but using the SDK provided by Google was not really possible because it was not open source. The second thing that was really bothering us is that people are used to being able to read anything when they use VLC. But the Chromecast doesn't understand nearly that much formats. So people are just gonna play it on VLC and they're gonna be like, oh, I want to put it on my Chromecast, but then the Chromecast doesn't understand it. So that doesn't work. Okay, VLC is not good. So what we did is kind of reverse engineer how the Chromecast SDK worked. When you're on your phone on YouTube, you have a Chromecast on your TV, and you want to play a YouTube video on your Chromecast, your phone is just a remote control. The Chromecast device is directly talking to the YouTube server, right? So what we did is VLC acts as the server. So your VLC app is gonna directly stream to the Chromecast. And the Chromecast, for example, let's say it understands H.264 and you want to play a DVD on your Chromecast. The VLC will transcode your media in real time. Transcode means that it's gonna change the format of your media in real time in a format that the Chromecast understands. All of this code is open source, so if you want to check it out, it's possible. So I'm gonna walk you through a couple samples from the repository that I mentioned just a bit earlier. Just starting video. No, don't come back. Okay. Sorry. So the first one would be the gestures and multimedia. If my Visual Studio wants to start. Yes. I'm going to show you the video first. So the video would be gesture GIF. Right. So this is a video that I recorded. It's a GIF. I recorded. So this is a Xamarin Forms application running on iOS on playing a stream of Big Butt Bunny, which is a stupid video that everybody uses to try stuff. Here I use Xamarin Forms Crossplatform gestures recognizers, which are tools that allow you to see how users touch your screen, and you get coordinates and information about what kind of gesture they're doing. So the nice thing about this is that when you're writing a multimedia application, you can actually give your user the possibility to manage stuff with gesture. I chose to be able to change the volume when you do a top swipe or down swipe, and the position, seeking and going backward if you do a horizontal swipe. The VLC for Android apps also does brightness change. When you swipe vertically on the left side of the screen, you can change the brightness of your video. Sometimes you have a very dark video, for example. Another one, I think that's this one. Yes. So I'm gonna use VLC to show you a video about VLC. Okay. Ooh.
There's some.
That's the VLC Android app, but it uses libVLC, so you can do it with Xamarin. No problem. So, code. Show me the code. Hello? Yes. Okay. I'm gonna zoom in. Okay. Okay. Can you guys see? Yeah? Okay. So, I'm just gonna show you quickly. No, that's not the one. So libVLC, that's the object I told you about, which is the main object which you need when you want to instantiate a media player. And then on the media player, you have a media property, which you can just tell if it's a remote stream or a local file. Just give it a URL with the libVLC instance, and then you can just press play on the media player, basically. So this is a gesture code from the small GIF I showed you about iOS. So when the gesture event is raised, you end up in this code, which, why is it gray? Not sure. So with this small condition, you can check if it's a left swipe, a right swipe, or a top swipe, or bottom swipe. And depending on it, what I do is, like, if it's a left swipe, then we want to seek to rewind. So I just check what time is it, what time on the media player is it, and then this is the offset. I store it. I just check that it doesn't overflow, and I format the message. What I should have showed you first was the view. If it wants to load. Okay, there we go. So this is a really simple view. Here you can see the pen gesture recognizer. I did an absolute layout here, in which I put the video view, which has a media player, data binded, media player property, and then the label with the message to display which swipe it was and the difference in volume or CT. Yes. So here, so we start the final time, and then this is in the gesture running case. In the case of completed, if the time change, then we just set the new time. If the volume change, we set the new volume, and then we clear everything, and that's it. So in a few lines of code, you can implement gestures for your multimedia application. Chromecast. I'm gonna show you quickly how the Chromecast app works. So, for the Chromecast, you don't need a view, because your view is a TV, right? So what you need is to discover Chromecast. How do you discover Chromecast with LibVLCSharp? Core initialize, that's what I wanted to show you. So core initialize is gonna load the native libraries in your application. So you need to do this before you start using LibVLCSharp objects. So we start libVLC with new libVLC object, and then Apple platforms use just a different renderer, which is this one, Bonjour, and the Android ones and Windows and Linux use micro DNS renderer. So you just have to know which one you need. It works on all platforms, but this sample, I added this just because this sample is just for iOS and Android. And then from that name, from that renderer description object, you create a new renderer discover with the name, which you can subscribe to item added, which it will be raised when they discover a new item. This is actually a C callback, which I bind it to .NET events, so it's easier to use from .NET. Then you start it, and when they find something, this will be raised from C code to callback in a C# delegate, which I bind it to a .NET event. And then you have this event, which tells you the name of your Chromecast, the type. For Chromecast, it's going to be Chromecast. For other stuff, I don't know. And then it tells you if it can render video and if it can render audio, because that's not a given. So we keep a reference to that. And when you want to cast to your Chromecast, you just create a new media. This is again Big Bug Bunny. Create a media player, and then you have a set render method on your media player where you just give it a reference to the item that you previously discovered, and then you press play. That's it. That's just gonna start streaming to your Chromecast on all platforms. So you don't have to change your code for any other platforms. I have other samples here, which I'm not gonna show right now, but it's all open source and you can check it out for yourself. Local network browsing, gestures. I have a PHP sample. That was just for fun, but yeah, there is a PHP compiler, which is a PHP compiler which allows you to call .NET from PHP, and I had fun doing some PHP code just to see if it works, and it works. And a video mosaic. Some people, they have like a lot of cameras and they want to be able to display all the feeds on one screen. So you can do this pretty easily with Xamarin, actually. I'm just showing you this view really quickly. This is a way to have 4 equally sized views. So you have one video here, one video here, one video here, one video here, same size. That's how you do it in Xamarin, basically. And this is all video views. This works on Xamarin, iOS, Android through Xamarin Forms. And you can just, yeah, you can do a mosaic. That's the name of the sample, video mosaic. Anyway, moving on. What's next? These days, I'm mostly working on a Unity 3D integration so that you can display your 4K videos in your video games. This is possible through this. So it's new. It's not available yet. It's nightly builds, if you may. This is the C code signature, which I will use. So on Windows, you have Direct3D, and on all other platforms, you have OpenGL, which is about to change, but still, for now, that's it. And this is thanks to this LibVLC API. You can hook into the the VLC rendering loop at a pretty low level, and you can have GPU decoding in your video games, for example, because you can show your video on a Unity texture, for example. WebAssembly, whenever LibVLC works on it, because right now it doesn't. Improve the media player, the media element. So if you want to know more, the main repository, all of our code basically, is at this URL. I have some blog posts about local network, Chromecast, mosaics, which explains how to use it, and you have URLs to find the code as well. The Nugget account, which I showed you, and VideoLAN on Twitter. I'm not the one tweeting, but if you want some updates about the VideoLAN community, you will be able to find it there as well. I think that's it. So thank you for listening, and thank you for hosting this event to decide. Any questions? No questions.